electric field intensity at any point on axis of uniformly charged ring. This is uniformly charged ring. This is center. This is axis. On plane of gold there is a ring. This is axis. Marker is axis. And this is observation point on axis. Say x. This is radius. Let a ring of charge plus Q and radius A. O is its center and P is observation point on axis and OPX. We know electric field intensity at any point due to point charge. Cut here point charge. Cut a point charge dq at A. Electric field intensity at A due to dq, that is dE, k dq by r square. R square is this distance of observation point from point charge. K dq K dq. AP say it is r square. And this is the direction. Put a test charge, this charge will repel. Let this angle is theta. Take another charge here. Then this will be direction of DE. It will also be theta, just opposite. ये यहाँ कोई भी पॉइंट लोगे डी क्यू, एंगल विल बी थीटा. तो in this direction it is d cos theta. Resolve this. In this direction it will be d sin theta. This is resolved. Resolve this. D cos theta. This is d sin theta. So this is resolved. This is resolved. Equal and opposite cancels. So due to 2dq in this direction there are 2d cos theta. Hence electric field intensity at P due to charged ring, that is it is integration d cos theta. Due to one point charge d cos theta, other point charge d cos theta, the total will be integration of this. And dE, it is k dq by r square cos theta, or it is k cos theta by r square dq, or it is k constant outside cos theta r square dq. Integration of dq is q. K 1 by 4 pi epsilon naught cos theta base. This was taken r. So cos theta x by r q r square 4 pi epsilon naught x cube r cube 4 pi epsilon naught x cube, it is a square x square 3 by 2. So this is electric field intensity due to uniform charge ring, and direction is this. Direction along OP. Special case, E at center of ring. Center x is 0. X 0. Therefore E is 0. At center of ring. X 0 put here. torque on electric dipole placed in uniform electric field. Questions. Derivation of torque. This is symbolic diagram for uniform electric field. This is dipole, minus, plus. It is placed like this. Torque on electric dipole placed in uniform electric field. Let AB is electric dipole. It is placed in uniform electric field E, making angle theta with E. Then force on each pole, that is F, QE, Y, E, F by Q naught. Here instead of Q naught there is Q. This is F. Y, direction of force on positive charge is direction of E. This is positive charge, this is direction of E, so this will be direction of force. Here this will be the force. That is, force is equal and opposite. And net force, it is F minus F 0. Now this force is toward this direction, this is toward this direction. Say this is marker. One force is here, other is here, it will rotate. And dipole will rotate. Hence, torque, that is torque, force into perpendicular distance. We have read in +1. RF, R perpendicular distance, F force. This is force, this BT is perpendicular distance. This is direction of force, this BT is perpendicular distance. So force F perpendicular distance is BT. F QE BT. BT by AB. We know AB. AB length of dipole. It is sin theta BT AB sin theta. BT AB length of dipole, it is 2A. 2A sin theta. Q into 2A is P. PE sin theta. Torque tau. P is Q into 2A, electric dipole moment, small p, or torque P cross E. That is torque perpendicular to P, torque perpendicular to E. This is direction. Direction of torque. Cross. So torque is perpendicular to and right hand screw rule. This is the rotation. Thumb is inside. Screw is going inside and in plane of, here it is board, for you it is paper. The torque is acting inside, perpendicular to P. This is P on board, this is E on board. The torque will be perpendicular to P as well as E and inside. So this is derivation of torque. B. Hence define electric dipole moment. We know torque PE sin theta. P torque E sin theta. If E is 1, sin theta is 1, then P is tau. This is definition. Electric dipole moment. of electric dipole is torque on dipole. इलेक्ट्रिक डाइपोल मोमेंट किसका है? ये डाइपोल का. इज टॉर्क ऑन इलेक्ट्रिक डाइपोल. दिस वन प्लेस्ड perpendicular to this one unit electric field. This is definition of electric dipole moment here. Otherwise the definition was this. This was the definition, this. Here it is this. Hence defined electric dipole. So P is torque when sin theta 1 means dipole placed perpendicular to unit electric field. C. When torque is maximum, torque P E sin theta if theta is 90, then torque is PE sin 90 or torque PE maximum. Hence torque is maximum when dipole placed perpendicular to electric field. When torque is minimum, another question. By torque PE sin theta, if theta is 0, तो torque PE sin 0 or 0 minimum, that is when dipole, see the figure, theta 0 when dipole is parallel to electric field, then torque is minimum. When dipole is in stable equilibrium, this is dipole. This is E. This is P, negative to positive. Now disturb this. Force in this direction, force in this direction, it will come again here. So this is stable equilibrium position of dipole again. Rotate. Force, QE again. So this is stable equilibrium position. Plot of stable equilibrium. This is plot. So when it is dipole is in stable equilibrium, when P electric dipole moment of dipole and E electric field are in same direction, then dipole will be in stable equilibrium. Net force is 0. So when net force is 0, then it will be in equilibrium position. Here net force is 0 as well as torque is 0. When dipole is in unstable equilibrium, now it is in equilibrium position, net force is 0. Force on this is in this direction. Force on this is in this direction. Net force 0, it is also an equilibrium, but unstable. ये क्या है? Plot of unstable equilibrium of dipole. Now disturb it. On plus Q charge, force is in this direction, on this force is in this direction, so it won't come back. So this is unstable equilibrium. When P of electric dipole and E are in opposite direction, then dipole will be in unstable equilibrium. Derive expression for potential energy stored in dipole when it is rotated in uniform electric field. This is uniform electric field. This is dipole. This dipole is rotated. Derive expression for potential energy stored in dipole when it is rotated in uniform electric field. Let A be electric dipole placed in uniform electric field, making angle theta with electric field. Give it small angular displacement. D theta. Then rotational work that is dW. It is tau d theta. But tau is P sine theta. So dW is P sine theta d theta. Hence, total work done, that is W integration P sine theta d theta from theta 1 to theta 2, P constant outside, sine theta d theta, theta 1, theta 2, PE minus cos theta theta 1, theta 2 minus outside. Value of theta is this, minus this is work done. Hence energy stored, that is U. Take minus inside, this work is energy. Cos theta 1 minus cos theta 2. Special cases. A. If dipole placed parallel to field, theta 0, putting in second, the energy stored will be PE theta 1 0, theta 2 theta, cos 0, cos theta, or it is PE 1 minus cos theta. B. If dipole placed perpendicular to electric field, that is theta 1 is 90 and theta 2 is theta. Putting in second, U PE cos 90 cos theta, cos 90 0, this is 0. The negative energy shows work is done itself. When this is field, this is dipole, it will start rotating itself. This means negative sign indicates the work is done itself. So this is when dipole rotated in uniform electric field. For numericals, if a dipole is held, then use this formula, held at certain angle. If dipole is placed at certain angle and rotated, then use this formula. dipole is held, use this formula. Means कहीं rotate करके रुक गया, use this formula for numericals. If it is placed at a particular angle and rotated through certain angle, this formula for numericals.